In part B, we have x squared minus 16 is the quotient, so it's box method again. We're given the quadratic answer, which goes on top. So 3x cubed minus 80. And we have x squared, and we have 0x, that's the key to this question. And we have minus 16. So we're working the opposite way around. We gotta get this one here, so it's gonna be 3x. We're gonna have 0x, and we're gonna have minus 48. And if we work from here, from the minus 16 times plus 5 will be minus 80, and then we can fill in our 5x squared. And that would be squared, and that does make sense for, here we have our 5x squared and our 0, and we want minus 48x, which we already have, and 0 by anything is 0. That's why these two are 0. So 3x minus 5 is the answer, or 3x plus 5 is the answer here. And if we line up px plus q, we get p to be 3 and q to be 5. Question 3a, write as a single fraction 3x minus 1 by 2x minus 3 on the bottom, and we multiply 7 by what it's not over, and then we have a minus 2 by the 3x minus 1 that it's not over. So we're going to get 14x minus 21 minus 6x plus 2, be careful with the signs, over 3x minus 1 by 2x minus 3. That's going to equal 14x minus 6x, 8x minus 21 plus 2 minus 19 over the denominator 3x minus 1 by 2x minus 3. In 3b, we have another box method question. Set up your box. 6x cubed, first term of the cubic, last term of the cubic plus 2. We're dividing in 3x plus 2. 3x by 2x squared is 6x cubed. We'd have 4x squared down here. We want minus 14x squared, so we need minus 18x squared in here. And then we have minus 6x to get minus 18x squared. Minus 12x, so minus 6x by plus 2. We want minus 9x, so I need 3x, and 3x by plus 1 will be 3x, and 1 by 2 is 2. So you can see we're correct here, and my answer is on top. And then this one, using factors to simplify, the top has to be 2x times x. 28 is normally 7 by 4, and you can see here you can get 7 and 8. We want plus 1, so plus 8 minus 7. And the bottom is 2 times x plus 4. So the x plus 4 cancels, leaving us with 2x minus 7 over 2. Here we have factors to simplify again. On top we have difference of 2 squares. By practicing these, you identify the type of question is really quickly. So we're going to have to, one of these factors will have to be on the bottom if we can simplify it. X by x is x squared. The only way to get 3 is 3 by 1, and to get a minus in the middle and a plus at the end, they both have to be minuses, so it's the x minus 3's cancel here, leaving x plus 3 over x minus 1. Here we're given a formula with S, U, T and A, 4 unknowns again. A is acceleration, S the distance travelled, U is initial speed, and T is time travelling. So find the distance travelled by a car in 20 seconds. Write down your variables. T is 20. If the car starts from rest, so the initial is 0, starting from rest, and travels with constant acceleration, A is equal to 8. And we want distance, S is equal to UT plus a half AT squared is the formula that was given. So just fill in your variables. S is equal to 0 times 20 plus a half times 8 times 20 squared, which is 400. And that's going to give 4 times 400, 1600 meters for the distance traveled. And we want u in terms of SA and t, so just simplifying u, we want u on its own. So if we multiply by 2, we get 2s is equal to 2ut plus 8t squared. So 2s minus 8t squared is equal to 2ut. So to get u on its own, I need to divide by 2t. So 2s minus 8t squared over 2t. And we're told the points P and Q lie on a straight road. A car passes P with a speed of u. And then, so we're looking for u. So they've given us S, A, and T here. So we can see A is 7. Sorry, for 7 seconds. So T is 7, so just double check. For 7 seconds at a constant rate of 10. Constant accelerates for 7 seconds at a constant rate. A is 10 meters per second. And if distance from P to Q, S is equal to 500, we have our 3 variables. U is equal to 2S, 2 times 500, minus A, which is 10, times T squared, which is 7 squared, all divided by 2 times T, which is 2 times 7. So that's equal to 1000 minus 490. 510 over 14, and they want the value of u. Let's get this, doesn't work out evenly. It's 36.43 meters per second.